Hello guys, my name is Diego Pacheco and this will be a slidecast video about architecture and design. Software design is a very important discipline. Right now, lots of companies they see value on design thinking, on strategic design, on um, UX, but often they don't see value or they don't have the mindset of be working with design internally for software. So this is not a UX presentation. This is about software and architecture. So I have a slide cast I want to show you guys today. So let's get started. So I call this Design 101. My name is Diego Pacheco. I am a cat feather. I am a software architect, also agile coach. I'm SOA and microservices expert, DevOps practitioner. I'm speaker and author. I wrote the book Building Applications with Scala. I also record the video series about building effective microservices with Java and Netflix OSS. Here is my Twitter handler, my GitHub handler, and also my blog spot where I blog a lot. So first thing we need to understand is about the designer, about the architect. If we are really designer or architect, or if we are just a server. For Lean, several times, people believe that your job is to deliver requirements, but we need to understand that according to Lean thinking, requirements are pretty much decisions, right? So requirements are allies in sense of they're not sacred, they're not holy, they're just decisions someone made, right? And as a thoughtful leader, you should be challenging that decisions, because someone could be not thinking through about all the possible use cases, about all the considerations, and might be a very bad idea or might have roles or something like that, right? So basically, you really need to think about that requirements, they should be challenged, right? They shouldn't be taken as something holy that you cannot question, right? You should be questioned, you should be challenging, because every good decision should survive a set of hard questions, right? If your decision cannot survive a set of hard questions, you need to be wondering, is that a good decision after all? Is really a good decision, right? And then people always take this as a power dynamics. You shouldn't be taking this as a power dynamics. Oh, I'm your boss, I'm saying to do this way, right? You should obey. No, that's not the case, right? The case is like how we harden our software, how we make our software more robust, right? And the only way to do that is to challenge our assumptions, right? So basically, an architect, a designer, you need to challenge the requirements. That's a very important starting point. Then we need to think about what's really design, right? Design is really subjective. I really like this Steve Jobs quote that he says that design is not just what it looks and feels like, but also design is how it works, right? So really, you are thinking about how something should work, and we can really extrapolate that how it works to several dimensions that we can think about. So let's think about this, right? So let's say we need to design a chair. So what will be the function of that chair? What will be the style? How many weight that chair is supposed to handle? There's resiliency properties. How long it should last? And you might be wondering, okay, but it could cost 10 reais or could cost 10,000 reais, right? So definitely, is a cost a boundary or not? We should be worrying about. What about the fabric? What about the material? So when you think about designing something, and software works exactly in the same way, you need to think about this sort of a properties, right? And we could really say that design is really about structure and responsibility, right? Because I don't think anyone would expect that this chair start to fly, for instance, or that this chair could be eatable, right? So basically, there's some responsibilities attached to the piece of software that you are designing, to the service or to the shared library. There is also a structure that you need to worry about, and I think that's kind of the two big things that we can split into many more other concerns, right, that we need to think about. So as your consumer asks you, okay, I want a chair, right? Then you need to start thinking about use cases, right? Okay, why do you want a chair? What you're gonna do with that chair, right? Is a chair to put in your living room? Is a chair for a stadium? Is a chair for a theater? You know, what kind of a use case do you have? And what sort of a constraints? Do we have size limits? Do we have budget limits? You know, is a chair for people? Is a chair for animals? No, so you really need to dive into this kind of multiple questions to understand the use cases we have, because we're gonna be designing thinking about our use case. It's not like we are designing for any kind of a generic chair that doesn't exist, right? That's called design by accident. You cannot do design by accident. Design needs to be carefully thought about set of use cases, right? So if we go back, all right, when we were thinking about the chair and we were seeing the structure and the responsibility, you need to remember someone ordered that chair, right? And there we come the use case. And sometimes, right, you can have multiple stakeholders giving you use cases. So it's not like you have one consumer. Sometimes you could have hundreds of consumers, right? So you really need or should do your due diligence, right, and understand your consumers and understand your use case and understand what kind of constraints do you have, because maybe you actually need to split your component or your software in more pieces to fulfill that consumers, right? So maybe it's not one thing you need to build, maybe it's two, maybe it's three, maybe it's more, or maybe it's one thing, right? So you really need to understand the problem space. That's why use cases and constraints are super important. And once you have that scenario, right, you have someone request you something for you in sense of do you have a problem space, that you have use case, that you have constraints, then you can think about the structure, right, and the responsibilities. And as you think about structure and responsibilities, you're gonna have trade-offs, right? You're gonna need to make decisions. And believe me, everything that we decide that has a benefit, it's gonna have drawbacks. Everything has drawbacks. If we cannot find drawbacks, it means that we are not looking hard enough, all right, or we don't understand our tooling enough, or we don't understand our problem enough. But believe me, everything has trade-offs, and you need to have, right? So you really should turn on a red flag if someone tell you that there's no benefits in specific choice by picking some library or framework, or by doing some algorithm, or approaching the problem in one way or another, right? So everything gonna have trade-offs. And as architect, as a designer, you really need to think about these trade-offs, right? And that's really, really important for you. So one thing you may be wondering, okay, but why this matter, right? Why this is important? Well, you can say that architecture, right? And lots of people say that architecture is, the cost of change that you cannot afford. And that's why you do design and architecture, right? Because if you could afford the cost of change of anything, why would you think too much in the first place, right? So all this kind of thinking, all right, and reasoning about and understanding the problem space and analysis and design is required, because if you get this wrong further down the road in the execution or in production, it will cost really a lot of money, right? It will be really unbearable, right? And could be a failure. It could be something you cannot afford at all, right? Just like to build a building. When the building is done and there's 10 floors on that building, you can say, okay, let's do it again from scratch. That's a massive amount of waste that you're gonna have there. So really is about cost. When you are thinking, when you are understanding on the problem space, change in decisions, in trade-offs, in structures, even in diagrams is cheap, is really, really cheap. It's not expensive at all. As you move forward, and when you have coding, when you are deploying production, it becomes really much more expensive. When you have lots of users relying, when you have a big ecosystem relying on that, that change is not trivial, right? It's not minor, it's really expensive. And then you must understand there's economical reason here, right? Design, software design, which is not UX design, but has the same principles, right? Because if you take a look on a UX design lecture, they will say to you that if they figure something on research, you'll be much more free than if they figure when you are there coding, right? And that's kind of the same idea. And that kind of a metaphor, I would say they steal from engineers, because in software design that was very popular, and that's the idea, right? So design is about cost. You want to save that cost and you want to get this right, okay? So there is Agile and Agile methods, and guys, don't get me wrong, I really like Agile. I'm consider myself a sort of Agile coach. I'm doing this for plus 10 years. I really like the ideas there and have lots of experience. However, I need to acknowledge that Agile was never really, you know, thinking too much or doing too much in sense of architecture and design, right? And if you take a look in Scrum, there's zero practices for design and architecture. If you look in XP, there are some techniques but they are really basic, right? Like coding standards, like doing TDD, and that things can help you, right? But they're really basic. They only will help you with the basics, right? As you are in a medium or advanced or principal level, this won't help you anymore, right? Because they're basic practices. They're not bad practices, but they are kind of a starter practice, right? And as you move on to more complicated problems, right, you need more practices. You need take design and architecture more seriously. So don't get me wrong, I like XP. I really like XP. I do XP a lot. I just don't believe that's not enough in 2020. So you need more than that. And I just acknowledging here that although agile methods are great, they are not really an example about architecture and design. And this is also true if you think about the other kind of design, which is UX, right? So agile methods was never talking about UX, right? That's something that happened later. And the same thing goes for DevOps. So many other things happen after the Agile Manifest and the Agile Methods, which was like a 90s and 2000 things, and they're still present today. And kind of Agile-ish is the default for every company, I would say. I'm not sure if all these companies they get the right principles and they're doing that correctly, but anyway, sort of Agile you're gonna see in every company. Right? But the issue is companies do not pay attention on this unless, right, they have this big scale, and there is the time where the cost strikes, right? When you are big, this became a big deal and a big problem. Then companies start to looking for software architects and software designers, right? But when they start, they really don't care much, and until it becomes a problem, and then is really like they're trying to have more architects and think about this, right? That's how it goes usually. I just want to point out something interesting about Hoop, which is this arcane method that nobody talks anymore nowadays, all right? But if you take a look at Hoop, there were like this sort of a phases or moment of your software, right? And everybody confused that with waterfall. That was not the idea. So you had this inception, this elaboration, construction, and transition, all right? And in inception and elaboration, you're really thinking about the problems, right? You're really, trying to bootstrap the project, thinking about, the use cases, how you're gonna fix it, and not necessarily writing down documents at the code level detail, right? But you should be thinking in sense of a strategy, in sense of trade-offs, in sense how to approach some problems, right? And that was a good thing about Rope that we kind of lose it, right? If you look in XP, you sort of have in kind of a inception practice there that's called Spike, where you can do kind of a architectural POC, or Scrum, they have something like Sprint Zero, but sometimes your problems are big and you can't do this as just one sprint, for instance, right? And that's something you need to acknowledge, right? It's like you know that American expression, you should throw the bathwater without throwing the baby away, right? And that's what kind of happened, right? Rational unified process had some interesting practices in sense of design architecture and really caring about that. And as we transition to the agile, we kind of lose that, right? And we need to recover that back. So I want to start now talking about what's a bad design before describing what are the properties of a good design. So a bad design, right, we could really say that's obscure, right? And obscurity, it means I really cannot understand or I have issues to figure out, right? So in the end of the day, obscurity is a great source of complexity. And obscure, it can be manifested and flavor of something hard to understand, or something that creates more bugs, right? And there's definitely techniques that we can apply to do our coding, sort of our libraries that we can use, and style of programming that could be really great for one thing, but they definitely could add more obscurity. If you think about like generic or event-driven, they're really cool and really useful for lots of cases, but definitely make reasoning more hard, right? Therefore, they can add more obscurity. And sometimes, obscurity in sense of solution, the easy fix is to write obvious code, right? Because if your code is obvious, if someone can read it and understand, you have clarity. You have the opposite of obscurity, all right? And if you really drill down into more details of the what obvious or what clear, and keep in mind I'm using the word clear, not clean, and that's by design, all right? So clear code, all right, it will be something that you can read quickly without much thought. You don't need to compile to debug it to understand it, and it's easy to guess or to grasp what the code does. You could guess how you can adapt that code, or how you can do updates there, or how you can write more of that code, and it should be precise and meaningful, right? You shouldn't be having second thoughts or dots, right? And this is really important because obscurity is really number one reason why we have complexity, right? And basically, a great tool to fight against obscurity is code review. If you do a proper code review, you can help to fight obscurity. But I would argue that the worst code reviews I saw it was because there was no strong design backing up. When you have a strong design backing up your solution, and when you're doing code review and your code is following that design, often that code reviews are really fast and really improving some small stylish, or catching some minor bugs, or improving a bit of the code in details. However, the worst code reviews I saw in my life was always when there there's lots of files, plus 100 files, plus 150 files, and there was lots of obscurity. And often when you start to review and say, okay, I don't get this, I don't get why I have this class, why it does this way, you're often uncovering a design issue, right? So if you have a strong design and you follow that strong design, your code review is definitely going to be easier, it's definitely going to be faster, and it would help you a lot to fight obscurity because you have clear, you know what you're doing, you know where you're going. Okay? So now that we understand a bit what a bad design is, let's think about what a good or solid design is. So a solid design, it has principles and has lots of principles like feasibility. You need to be able to implement that design, right? That's the number one quality. The second quality is testability, right? You need to be able to test. And some folks may say, oh, that's where TDD can help you. Well, sort of. TDD can help you when the basics, right? So you make sure you don't have all the public methods with void and shared multiple global states. So it's a mess to refactor and it's a mess to test it, right? But once you overcome that, really TDD won't give you much, because TDD is tactical and design is strategical, and we're gonna talk more about that later on. But really, TDD is kind of a basic on that sense. So testability is one important thing on the design. All right, I don't believe at all that design can be wrap it up as just if you write good tests, you're gonna have good design. If you have good design, you're definitely gonna have good tests. But if you have good tests, not necessarily gonna have good designs. All right, so that's important thing to point out. A good design need to have maintainability, so it should be easy to maintain, right? It should be debuggable. You should be able to understand what's going on, but it should not need debuggability, right? And debuggability should be for production. If let's say there's an issue, you should be able to debug it. But if you need to debug it to understand, that's a problem, right? So here debuggability is more in sense of observability, right? Which is the next property. So you need to be able to know what the code is doing. If your tools are telling what the code is doing, so you have metrics, you have centralized logs, you have dashboards, you don't need to debug it. So often you need to debug as a last resort, because your tools don't tell you what's going on, right? Your test was not able to catch it. Your observability is not able to give answers, then you need to debug it, right? And that's why you need to word it as debug it, but as not to understand, but as a less observability resource. And we also need flexibility, right? A good design, it gives you some degree of flexibility and also extensibility. Extensibility doesn't mean you need to have POJOs for everything, and everything needs to be public, and everything needs to be on IOC with dependency injection. That's not true, right? You should have some points of extensibility, right? But that should be thought about it, all right? And should be carefully thought about it. And you shouldn't say, okay, I'm gonna make everything public. I make all POJOs. I'm gonna put all in Spring, right? That's how I have extensibility. You're definitely gonna be hurting encapsulation. You're definitely gonna be hurting other important properties like information hiding that we're gonna talk more later on. So this is not as easy as, yeah, I just use IOC for everything. No, that doesn't work like that. Design is not by accident. Design needs to be thought about it. Okay, so now that we understand some properties, let's understand some principles, right? If you have a good design, you're definitely gonna be following these principles. And the first principle is called SOC, or separation of concerns, right? So basically you have different concerns that are like water and oil, that you do not want to mix that together. You want to split it, all right? And that's really important concept in design and architecture. So you need to figure out what you can go together and what you really should be split, all right? And that's really separation of concerns. Another principle behind the design that people really don't get it, all right, and that's really controversial topic, is what a good abstraction is, right? So I like this quote from Bob Martin, where he says that abstraction is the elimination of irrelevant and the amplification of essential, right? That's what Bob Martin say that a good abstraction is. So the tricky thing is that you could see that abstraction with different points of views for different use cases. You might have different schools, all right? You might be more conservative, that you want to write, much more tests up to front, or you might be more, agile. You want to make sure the business have value to then add more structure there. So that's definitely schools of thought that might influence your decisions, right? But you need to understand that a good abstraction is not just as I see it. Let's say, what is bad abstractions, right? Or what are the traits that you're gonna go, or that you're gonna make, and that will result in bad abstraction, right? And one trait could be that you're just delegating, right? So you have a class that just delegates to another class, right? Let's say you have 10 or 2 lines of code. You are not doing much, right? So that's not a good abstraction. If the abstraction is not doing much, it's not a good abstraction. Think about as a business, all right? So you have money. So would you pay your money to someone just tell you a number? Probably no, right? So you need some product, right? Some value, some service. That's something that you cannot do easily, or you don't know. So that cannot be one line of code, right? Think about that way. So, and another thing I would say, all right, is how you kind of express your API. Sometimes people want a fluent API, or sometimes people want one-line method, right? And the API is kind of a verbose. And lots of times people create these utils because the API is not fluent or verbose, right? Instead of doing this, you should fix the API, right, and make the API more fluent or less verbose, right, rather than be this utils proliferation, because that are not abstractions, right? So I think that I hope that ideas help you through. So another very important principle is isolation, and there's lots of connections with microservices here, right? In isolation, we're gonna see it in object orientation, right? OOP, you're gonna see isolation. Functional programming, you're gonna see isolation when we think about state and disciplined state. When we think about Docker, we're gonna think about isolation. So isolation is really a core concept in design, right? So if you think about object orientation, right, isolation, it manifests through encapsulation, right? So encapsulation equals isolation. And basically, let's say if you have a small class level, right, you kind of abstract the state and the implementation details, right? So you do not expose the class internal state and do not expose internal implementation details. So you really have kind of a state, you protect that state, and around that state you provide an interface, right? And if you think about service orientation, SOA microservices, that's really similar to the idea of a service, right? So if you think about a proper microservice, you shouldn't be sharing your databases, right? If you think about the database similar like your properties in your classes in Java, it's like the same deal, right? It's your internal state that you do not want to expose directly. And the reason why you don't want to do that is the same reason for microservices or for object orientation, right? Because, or functional programming, because all different concepts with the kind of the same core ideas, where the reason why you don't want to share or show that things are you want to have control, right? And as you expose, you lose control, and you kind of weaken the abstraction, right? And if you weaken the abstraction gonna lose value, right? So let's say, would you pay someone to do a Pojo for you in Java if you already know how to do it? Probably not, right? So you really need to be getting something from it, right? And that's kind of a property of control. Another thing that proper abstractions need to do, right, is it needs to hide stuff, right? You need to protect it, because if everybody's using, you are blurring your internal state with your publicly contract, and you might be doing contract by accident, right? So is same for your internal databases, no matter the technology, or for your Pojos, for your properties that you have inside your class. And that's a very DDD idea as well, right? And finally, for safety, because probably who is accessing that could be, violating some property or could be creating some trouble for themselves. So that's why you really, for safety reasons, you don't want to expose some internal states and some internal constructs. So that's the principles about isolation. And the same ideas we can see in Docker, for instance, right? Where you have a proper, image of a solution with their own, small operational system there. And if we keep going through, the idea that we are going from microkernels, right, to specialized hardware is more and more to have specialized software, which means isolation wins, right? So isolation is really important property of design, is everywhere, and you need to consider. So you need to consider it on the micro level, but also on the macro level, right? So on the micro level, in your classes, in your functions, all right, if you're doing FP or OOP, but also in your macro design, in your services, and your corporate architecture, right? And that's why isolation matters. If you don't pay attention, right, you could end up with a binary coupling. Binary coupling is not a good thing, right? Binary coupling is a bad thing, is an anti-pattern, right? So, and often we do binary coupling because we use libraries without much thought. We just add more libraries, we never think about it. So let's say if you're doing Java, if you have a Maven file, or if you have a Gradle, right, you just add dependencies there, right? And what's the trouble? Well, the trouble is when you make dependencies and you ship these dependencies for other consumers, right? Because let's say you have an abstraction for quote unquote for a login or for security or for persistence or for something like that, right? And the issue as library provider, right, as designer, whatever library you add there, you're gonna impose preferences to for those who consume your library, right? And that could be bad for several reasons. First of all, is because you're gonna lose the main benefit of a microservice or a service, which is isolation, right? Because as you are controlling the libraries, not only as developer, you don't have more control of your class path because there's third-party library providers adding things there, right? And often enterprise companies, they do that. They call it frameworks or they call it shared libraries, right, that everybody uses. And that's really bad because you lose your ability to have technological diversity. You lose your ability to have freedom. So oftentimes when you need to change one of these libraries, you need either change all of your consumers or nothing. So you're really stuck, end up making everybody be stuck in old versions, and having bugs that you can't be fixed. So let's say there's a team who wants to experiment, it can't. So you really, in the end of the day, you think you was doing good, but actually you end up doing really bad, right? Because you lose your ability to do in-place updates, you lose your ability to have technology freedom, and you need to update all the services or nothing, right? And if you think it through, why we went to microservices on a Flare, first place was to be able to scale and be able to do things independently. So you cannot do things independently anymore, right? So that's a problem. So you really don't want to do binary coupling. So okay, so how do I avoid binary coupling? Well, you need to be minding what you add in people class path, right? And there's techniques you could do with that. If you look in my YouTube channel or in my blog, you're gonna see there's a post about the death of microservices where I cover that in more length if you are interested about it. Finally, I want to talk about design in sense of being strategical or tactical. So design needs to be strategical, right? If you are being tactical, you're never gonna have a good design, and that's kind of the issue with TDD, because TDD is tactical, is feature by feature, and design is not feature by feature. It's about the big picture, right? So strategic means your goal is to produce a good design, right? You want to simplify feature development, you want to minimize complexity, and it must to be sweet the small stuff, right? And you need to have this kind of investment mindset where you need to take extra time that will pay on the long run, right? If you're just delivering features, right? If you work on a feature factory, it's just delivering features like crazy, and you're not thinking about the big picture, you're just doing tactical work. That work gonna have waste. That waste will be turning in technical debt, and the long run, you're gonna kill your ability to produce the same features you want so much, right? So really, you need to have these moments to think about in a more strategical fashion in seeing the big picture, and that's how, all right, you kind of improve your design. Another super important concept that came from a book called Philosophy of Software Design. Actually, the previous concept is from that book as well. All right, is there in this challenge clean code a great deal. All right, is the idea of shallow versus deep. All right, so basically your classes, different than what clean code says, they should be big, they should be fat, right? And I remember some time ago when there were these DDD videos on the internet with three chubby kids, talking about DDD and Ruby and Rails. There were some funny videos on the internet, and they were always saying like, how your model should be fat, right? And that's a kind of a DDD principle, right? You don't want to have an anemic model, right? Where your model doesn't have value, right? It's just Pojo, right? And that's kind of the same DDD principle here, right? And if you think about SOA, is the same principle as well, right? So SOA never prescribed size, so there's no micro in SOA. If you want to do micro, you can, but often SOA implementations tends to be more intense, more coarse-grained, all right? And the idea is that as you have more classes, and they are deep classes, right? If your classes are shallow, it means that your value added there are not really much. And if you think it through, this makes sense. As more things you do, more value you're gonna add, right? And not necessarily splitting in 3,000 classes makes easier. Actually, could make harder, right? And we got this idea like a monorail that all the classes should have like 10, 20 files and 10, 20 lines, and that's how it's supposed to be. But actually, that's not the case. That actually creates weak abstractions that's really hard to reason about, and you don't have a good understanding about the system. And the idea is that your interface it should be shallow, but in your implementation it should be deep. All right. And in that case, what you want to do, you want to pull complexity downwards, right? Like an iceberg model. So the complexity is all downwards, and in the surface where you have your public contract, your interface is obvious. Your interface is damn simple, but your implementation can be complicated, and that's the goal, right? It's important to say that because, often in software, we kind of have hammers and everything we see in front of us are nails, right? So we need to be able to thinking about diversity and, different schools of thought, different technologies. We shouldn't be using just relational database for everything. Don't get me wrong, relational database is a great solution, is mature, everybody know how to operate and to scale it, but it doesn't mean that all solutions and all use cases will fit perfectly there, right? So you really need to using the right tool for the job, right? And you need to understand that design is not something concrete. Design is organic, is live, is something like you will need to keep doing all the time. It's not something you do once and you never ever do it again. No, it's something live and organic, right? That's important. But design can be really tricky because if you do a bad design, it will be probably worse than having a monolith solution, right? So functional programming talks a lot about this, that absence of a structure. If you think about a monolith class with duplicated code, is much better than a bad structure, because a bad structure probably is used everywhere and therefore is coupled, right? So that's a funny thing to think about, all right? Let that sink it in for a minute and think it about, like, duplicated code in a monolith code base is decoupled, right? And your small class that you think is okay is coupled. Think about that for a minute, right? And that's the thing, right? When you design something, you need to make sure it's correct. Otherwise, it's better to do monolith things because they will be much easier to refactor. And because of that, right, you need to think design in sense of waves, not steps. And the reason why I don't like steps is because the steps are incremental and you should be complete, right? If you think about startups and lean startup, probably saw that image about building a car step by step versus having a skate and then a bicycle and then a bike and then a car, right? So that's kind of the same thing. So design should happens by waves and by complete waves. And if you think about design before you code it, you actually can have more than one design. You can have several designs, right? You can think about 3-4 different solutions, you can compare them, you can visualize, and then you can pick the right one you want to use. And that's why thinking it's cheap if you're doing before is in production. You can use tools to help you. I really like UML in colors because you have archetypes. This is a project I did for the Silicon Valley some time ago. Is Cassandra deployment and cluster orchestrator called CM. If you look at my blog, you're gonna see more about it. So the modules here, the internal state, are captured in gray. This particular solution have lots of tasks and background tasks that run in Quartz in Java, and these tasks are captured in purple. Basically, the service classes, the managers, the classes that control flow are in light green here, and third part exporters integrations are in this dark green. and basically, my REST endpoint is in um, orange here. So the colors help you a lot because you see the color, you know what it does, right? So definitely a great tool, and especially like these high-level class diagrams in UML, they're really useful to you to think about the relationships of your systems and how they goes on the implementation. Is great for exercise. Which leads me to my next subject, which is design review. All right, so sometimes it's really subjective, the design work that you might be doing. So the best thing to have is a review process that can help you not only to improve as designer, but also to catch gaps and roles before it became cost and before they're going to production. So the benefits of this design review process are many. I can say for short that will definitely improve your team ownership of the solution. Is a great ownership exercise, and also if you think about it, you are saving cost in the end of the day, both time and money. So for a design review, I really like the practice of a design doc, right? This could be a PowerPoint. In the past, I played with so many formats. I did PowerPoint, I create like architecture canvas, I did with Google Docs, so it can really be text or visual. So you pick whatever format works best for you. But that's kind of a standard practice in Silicon Valley. Uber does, Netflix does, several companies, they do these design docs, right? And you kind of have an informal way to do these design docs. They often could have different sections and different content, but you don't want this to be huge, right? So you definitely don't want to be more than 15 or 20 pages long, right? You also don't want to have code there. This is not a software factory anti-pattern, specification, 300 page specifications. Hell no, right? This is a lightweight design document, right? So you want to have the business context, so you understand why you are doing that design, what's the relationship with the big ecosystem that your company have, what goals do you have, and it's really important to say non-goals. What are the things that you won't do it at all? As you have multiple consumers, that's really, really important. The principles that you're gonna follow, and describe the design, right? And the most important things to describe in your design is your trade-offs, right? So you can express what trade-offs did you think about it, right? And you should document that. You also should have a couple of diagrams. I would say don't have many diagrams. Overall diagrams or class diagrams are pretty useful. Sometimes, sequence or deploy diagrams can be useful, but I would say it's not every time, right? Most of the time I would say they're not useful. So you should be really lean in sense of your diagrams. You should also say other solutions you consider, other architectures, other approaches, other libraries. I really like to put like observability specs there, and it could be in sense of system observability, like what metrics you should be exposing, what information should be going to centralized log. In sense of business observability, what are the metrics that the business care, right? And we should know that metrics, and we should know why they care about it and what we're gonna do with that metrics. And I think that's really great. And finally, you can have some reference, right? You can link to your Jira ticket or to your GitHub repository or stuff like that, right? And that's how you can write a design doc. Then you can do a design review, right? And a design review for me, there are two actually practices here. One is the design session, and another one is the design review itself, right? So let's say you did the design, you have a design doc, then you can have a design review session where you can make a call. Now with COVID, that's what we need to do, right? So you go there online, you share Google Docs, and people can make comments, people can discuss it, make sure that everybody's on the same page, and you are hardening your solution, you are making your solution better. Right, and a design session is actually something maybe you do before you write your design doc, that you gather together. Right now, unfortunately, we cannot go to a whiteboard. I love to do this with whiteboard with sketches with folks, but now you need to do online. Some tools like Zoom, they have Annotate. There is some online tools you can use as well. If you do Google Slides, you also can collaborate everybody drawn together. There's tools that can help you to do this. And then the idea is like, as together you might think about sort of a solution, or understand the problem space, and that you will do before you do the design docs. All right, so basically you want to do some kind of a problem space that you want to explore in sort of a DDD like. Then you want maybe to do some whiteboard design sessions. Then you want to create a design doc. Then you want to review, and then you want to implement that design. Should be doing this story by story? Well, maybe not. It really depends of the complexity of your system. If you do this by story, they should be really short, maybe 1 or 2 pages, all right, super lean. But in the past I did both models. I did story by story, and I did per service, right? I feel like per service is better, but if you don't start with the design, since the day one will be hard. If you get a code base that's there, right? Then you can introduce story by story until you have a service design, and then you don't need to do story by story, right? But that really will change from complexity and scenario that you are in. And I really would say that you do not want to add code there. You do not want to make this like a big design up to front in sense of expressing how the code will do, unless you're creating an algorithm, right? Unless you have a specific algorithm, then I think will definitely be benefit to describe that algorithm. But one thing that I want to point out, if you think about the problem, that's not big design up to front, right? Because in Agile, there's this anti-pattern called BDUF, big design up to front, and people really scared about it, and often they go, before Agile, people was going to one extreme. People were really not thinking about it. People was not really designers. They didn't know the language. They didn't know software design. There was just people writing down whatever the business asked, right? So there were servers, right? And Agile came and said, hey guys, stop. Let's build the code and forget it. And I agree, it's much better. However, some problems are hard, and you really need to think about it. And to think about it is not to get a ticket from the business and code it, right? It's to challenge, it's to think about it, right? So you're not a server in that sense, right? And basically that's not BDUF, right? To be plain and clear. Okay, so finally, I want to share some books with you guys that I think it definitely can help you out. So there's the classic Pragmatic Programmer. There's the classical Gang of Four 24 design patterns. There is implementation patterns from Kent Beck. There's clean code. Although there are several things now today I don't agree with clean code, and I think there's things that are better there. I really recommend you read it, because lots of people follow clean code without reading, and that's kind of a tricky. I don't know how people do it, but I don't think that's the right things in some sense. Like I don't think everything is there is ideal, but I think you should read it. All right. Then there's Code Complete, also an awesome book. There's Refactoring for Martin Fowler. Recently there was released a new edition, really good. XUnit Test Patterns, really good for testing. Refactoring to Patterns, really good job, really good book. Joshua Kearsley is the same guy that created the Modern Agile, a really awesome book. If you are in the legacy application, it really can help you out. And for me, the best book about software design, is a recent book. I think 2007 or 2017 or 2018. I think it was 18 or 17 or 18. But it's really the Bible of modern design, a philosophy of software design. It really goes in a different direction than TDD and clean code. It's a short book, 150-ish page. You should read it. It's really amazing. Lots of ideas on these presentations. I definitely, got from a philosophy of software design. So I really recommend you read this book. You're really gonna like it. It's really good. It's really, really good. So that's what I got, guys. I hope you like it. I recommend you take a look on my blog and my YouTube channel. I always posting things about architecture and design. Even if I'm doing language specific videos and posts, always try to talk about design and architecture on that context. So that's what I got for today. I hope you guys like it. See you next time. Bye.